Hello everyone. So today we are going to go over files. Okay, so before today, every time we are dealing with any C program, we was just going over the output on the screen and that's it, right? So for example, like using most of the time printf and then printing on the screen whatever the output we want, and then after closing this program, we are not getting this output again, or we are not saving the output itself, right? So this is why actually we deal with files in order to make sure that we are saving the output from whatever program you're writing, and at this point you will just keep this output forever until you decide okay, I don't want this output anymore, or let's say you are going to draw curves, or let's say get some output or bar plots or whatever you want to do with the output, and then after that you will decide to delete it or keep it forever, whatever. In this case it will be on, let's say, a flash drive or hard disk on your computer. Okay, so if we are going to deal with this, at least now we have to have a way to deal with creating files, modifying files, saving files, deleting files, right? So this is why actually we are going to deal with files. And a very good point to talk about now is that files are mainly dependent on pointers. If you remember, when we was talking about pointers, we said it had a lot of advantages. One of them actually is files. Why? Because the pointer will point to the file in the memory, right? So for example, if I created a file and then I will have the pointer pointing to the first address in the memory for this file, and then writing to this address, the pointer for this file will go to the next address, and so on and so on. Okay, so this is why actually while dealing with files, we are mainly playing with pointers. So for example, creating a file in the memory, the pointer will be in the first place, right? And then let's say I'm writing, the pointer will go after whatever you wrote. So you wrote in the first address, the second, the third, so the pointer will be ready on the fourth. Okay, and then we will know advanced ways actually to change the pointer from, let's say, the third address to the fifth address and so on. And also you can use seek or try to search within the addresses of the file. So a well-known syntax here is while you are dealing with pointers, we are using file asterisk, okay, just to identify the pointer to the file. Okay, so the basic parameters you have to deal with, the first thing is the name of the file. The second thing is actually, are you going to read, write, or append? What the meaning of append, let's say you open the file and wrote inside the file introduction, and then after that you will close the file and then open it anytime. And when you open it again, if you have append, this means that you will add to introduction, right? You will not overwrite anything. You will just add, let's say, introduction to C. So you will write to C. Okay? Okay, so if you want to create a new file, you have different ways actually to do it. The first thing is to create this file on your computer. So just if you are using Windows, you can right click and then new file. Let's say it's a txt file, and that's it. Another way is while you are dealing with pointers, you will just go with write file. So the system actually, or one compiling this file, if this file is not existing, so the compiler will create the file for you. But this is if you are dealing with write or append. This can't happen with read. Okay? So let's see the first example here. So as you can see, this is a very short program, which is starting with the main function and then file pointer, which is called fp or file pointer, and it's pointing to null. And then in the next line, okay, we are having find pointer equals to f open and then text.txt. This is the name of the file, and then w, which is an abbreviation for write. Okay, and here fp is the pointer that I'm using with this file, right? So this is the pointer that returns a pointer to the file which is named text.txt. Also, fopen is a function call, and this one is just opening the file which is named text.txt in in write mode. Okay, and again, if this file doesn't exist, when compiling this short program, you will find that a file was created in your directory. Okay, so here, every time you are dealing with pointers, and if you remember when we was dealing with pointers, we said the same thing. You have to make sure that you are checking if actually the pointer is assigned, right? So in this case, here I'm doing the assignment. Okay, here's the pointer, and then here the assignment, and after that I have to make sure that the pointer is actually pointing to something and not pointing to null, right? This is why every time you're dealing with files or pointers, okay, let's say you are using mallocate or something, after mallocate you have to use the same thing, which is if the pointer is still pointing to null, in this case, hey, you have to give me an error message, because normally C compiler is not giving you an error for this. You will find that when running the program itself, you will find error message called core dumped, and then nothing else, and then not giving you any information where is the error happening. Okay. Okay, so let's see a quick demo for that. So here, let me go here. And let's look at the files that we have. So ls, these are all the files that I have in the directory. And Z, we have only zybook and zybook1. So let's go here to the program which is called file intro. And as you can see here, I'm writing the file pointer fopen, and then I have a file which is named z intro to c.txt. As you can see here, I don't have this file here. If you go to Z, because this is alphabetic files, you will find that at Z I don't have this file, right? But once you run this program, you will find that this txt file will be created in your directory. So let's try to run here. So this is gcc file intro.c/o file intro, and then now it's okay, compiled. And let's now look at the files. We still don't have anything. Then let's now run the file. So here, files intro, okay, and let's now look here. We will find that the file is already created for you, right? And then after that, I didn't do anything here, so I just opened the file and then closed the file, and that's it. Okay. So returning back to our slides. So as you can see, we have close file. So what is close file? Every time you are opening a file to do something with it, if you didn't close it and you close the program itself, you will find that the file will be closed automatically. But sometimes there is if you didn't close your file or forgot to close your file and then did many things other than that, you may forget and mess up something in your file. This is why it is recommended that you use or you close the file, which is fclose, to make sure that nothing is altered on your file. Okay, so every time you are writing a file, make sure that you are closing the file, which is, as you can see here, the last part. We are just closing the file, right? So fclose and then the pointer name, and that's it. In this case, you are making sure that the file you already opened to do whatever you want to do, you are now closing it. Okay, so now we saw an example for just opening a file and then closing it. Let's now see how to read. So if you are dealing with read, you have to have the file. So compiling and running will never create a file to read, right? So in this case, you have to have your file, which in this case, I have a file here, which is named data.txt, and the file is having 2 columns. Okay, The first column is having an ID, the second column is having a score, and now I want to read from this file. So to read from this file, I will use something very similar to what we used before, which is having scanf, but this time we will use something very similar, which is called fscanf, which here the F at the beginning is just for file. So file scan, and that's it. Okay, so this is the main function that we are going to use to get the data from the file. So let me just identify this. Okay, and then if you look here, you will find that we are writing just a program to read the data from the file, and here again file pointer, and then I have here fopen and the name of the file, and now we are saying, hey, we are just reading, right? Read only. And then after that, making sure that the pointer is assigned to the right file. Okay, and then the next step is using fscanf, right? So fscanf here is going to have the pointer name and whatever you want to scan. And here we have two columns, so this is why I have %d, and then the first variable, the second variable. Then after that, I have printf, which is going to print whatever I scanned from the file, right? And finally, I'm going to terminate that. So as you can see here, the fscan itself is taking the file pointer name as an input, and then your variables that you want to read. Okay, so let's see now a quick demo for the file that we have. So here we have the file which exactly is the same as the one in the slides, and here this is the program that we just went through. So let's try to run this program. So starting over here, and then going with GCC, and then the file name, which is called filesread.c, and then going after that with files read. Running. We will just read the first row here, which is ID 23 and then score 555. So in this case, we just only read the first row. So what if we want to read the whole file? So again, I'm just reading here one line, okay? And if you remember, as I said, once you read the first line, the pointer will be ready at the second line. So if you scanned again, you are going to scan starting from the second line. Okay, so if you want to read every single line in this program, I can just go over all the lines, right? But I have to stop at a certain point. How I know that? By using a function which is called file. Let me just point to it here. Yes, here is the pointer. So I'm going here to have file end of file function. Okay, so what is this function doing? Every time you are not at the end of the file, it's returning 1. Once you are at the end of the file, it is returning 0. This is why I will have the same program as before, but in this time I will have a while loop. Okay, which is while 1. While 1 means that it will run forever, right? Until a break statement will stop it, right? So I have here a break statement, and this break statement is with f end of file of this pointer was there, right? So again, if I'm at the end of the file, this will give 0, and in this case the if statement will be implemented, and I will go to the break and break everything. If not, so you are just scanning, right? And then after scanning, printing whatever you scanned, and then incrementing I to give I here, which is the line that you are there. Okay, and after finishing everything, you are just closing the file. So again, here you are first scanning, and then after that, mainly make sure that you are not at the end of the file. If you are not, so you are going to the next iteration, and so on. Okay. So now we saw how to just create a file, how to read a line from the file, how to read all lines from the file, and now let's see how to write to a file, right? So it's exactly the same as before. So if the file is not there, don't worry. It will be created for you. Once you compile and then run, the file will be created for you directly, right? And then after that, you are going to write, or you can use the append mode, okay? And then finally, to print anything that you already read from the file or wrote to the file, or let's say it exactly, to print to the file, you have to use a function which is called fprintf, which is exactly the same as printf function, except that you are using f, which is file printf, right? So file print function. So this function is used to print to a file. And remember that something very important here, printf, you are writing whatever here, whatever you want to print, right? fprintf, you are writing here the pointer name, right? So if you used here standard out and then whatever the data you want to print, this will print directly to the monitor. And the same thing with the scanf. If you use the scanf and with the scan or fscanf, and with it you wrote standard input or stdin, in this case it will read from the keyboard. So in this case you are converting fprintf to printf and converting fscanf to scanf. Okay, if you use the standard input, standard output. So let's return back now to write data to file, and let's see this example. So here, starting with the main function, identifying two or declaring two variable, ID and score, initializing I to 0. And then I have an array of doubles, is having 7 elements. And then the regular way of doing it, having a pointer pointing to null and then pointing it to the file, right? Which is called write.txt, and making sure that everything is assigned right. So the pointer is pointing to the file. And then after that, if you look to the while loop, so while I less than 7, so this means that I will go from 0 to 6 because I is initialized to 0. And then here printf writing element percentage %d equals to percentage %f to file, and then having after that fprintf file pointer, right? And then percentage %f and then I and array of I. So this means that you are just going over all iterations, right? Taking at each iteration one element of the array and then write it to the file, right? And again, make sure that the fprintf is exactly the same as printf. The only difference is that you are using fp, right? Or giving the pointer to this file. And if you used instead standard out, in this case, you are just printing to the screen. So if you run this program, you will see something like this. On the screen, you will find writing element 0 to 3.14 and so on. And then in the file itself, you will find that 0, 3.14, 1, 2.45, 2, 5.0, and so on. Okay? One very important thing that you have to make sure from, if you are opening a new file to write inside, you can use write, which is W. Okay? But if you already wrote something, closed the file, and opening the file again, if you use W again, you will overwrite everything there. But if you use append, in this case, you will continue whatever you stopped at. Okay, so append will take the pointer of the file to the end of the file so that you can start writing there. But write is having the pointer at the beginning, so every time you will overwrite whatever you wrote before. Okay, so I will just upload to Canvas one file which is called files overwrite, and then another file which is called file or files append, and if you run both of them, you will find that how actually you are in the first one overwriting whatever you had, and in the second one you are not overwriting. Thank you very much for listening.